the potential of AI in optimizing complex water treatment system. So let's look at the stress. We are talking about water stress and demand supply imbalance. We have stress when the water demand exceeds the available supply. So it's an indication of pressure on water resources. So let's look at several factors contributing to this imbalance. One of them is the population growth. The population is growing, and then also the demand for water is growing. So people are putting pressure on water. Then you talk about economic growth also. Economic growth or industrialization drive higher water supply demand, both for the industry and also for energy production and also mining. And then when you talk about agric is the highest consumer of water supply. About 72% water we produce, fresh water, they go into agriculture, 72% globally. And then the issue of urbanization also affects water stress. The issue of urbanization, if you look at the whole thing, the more you have more cities, the more you have the quantity of water. And then you talk about also another one is the climate change. Change in precipitation pattern and the rising temperature, they affect water supply also. So So let's talk about sustainable water management system. Sustainable water management system aim to ensure long-term availability and sustainable use of water, while considering the social and economic and environmental dimension of it. So let's look at some of the strategies we have there. One of them is water conservation efficiency. We can only drive water conservation efficiency with technology and education. That's one way of doing that also. We can adopt, another way of doing that is adopting the integrated water resources management technique. And then also, if you live in a community where people don't have access to water, you can harvest water. In the process, you're augmenting, you harvest water, you use the water to augment. And then also in the area of water reuse and recycling, these days you can recycle water. Then after recycling water, what do you do with the water? You can use the water. You can use it for non-potable means, or you can use it for your agriculture. Then you talk about sustainable agricultural policies. You know, when we talk about precise, irrigation and other things, you can do that. In the process, you're preventing pollution, because at the end of the day, when you apply fertilizer, it goes into groundwater to pollute groundwater. So in the process, what you're doing is that also you can also introduce the rotation. You rotate, you plant here this year, you move to that place. In the process, you're also preserving the ecosystem. That is one thing about preservation. And then you talk about the governance also, very, very important in the area of governance. You know, we need policies that will be enshrined, that will let us know that water is right. Everybody is entitled to water. So now, presently in Nigeria, we have under water governance and policy framework. We have a National Water Resources Bill. The thing was in National Assembly last time. That's the 9th Assembly. They didn't pass it. You know, that bill provides guidelines and principles for management and development and allocation of water resources. That's one of the bills, a good bill also. We also have Water Resources Act of 1993. And we also have NIWA, we have Water Institute of 1985. We have National Water Policy and National Supply and Sanitation Policy. But effective governance in Nigeria requires involvement of all the stakeholders. The stakeholders must be involved in that also. And another one is the Transboundary Water and International Cooperation. We need that. Nigeria engaged in collaborative efforts and bilateral agreement to promote shared management of transboundary water resources and also resolve a related conflict. Then in area, we're able to work on using feed-forward neural network for precipitation and river prediction. That's what we work. You can see the architecture there. You have the input value there, you have the hidden value, you have the output value there. That's the value we did. So we're able to work on that, and we're able to use it to compare with the existing value, and we're able to predict the water, we're able to predict precipitation and also river level. And then to calibrate it, you know, remember what I told you? The first thing you do is to train the model. The second one you do is to test the model. And the last one you do is to validate the model. That's what we normally do. So we're able to check the accuracy of the model by using mean square error and coefficient of correlation, which indicated a very effective one. That's my contribution. So in the area of what do you call it? Water, energy, food nexus is very, very important. This is a new concept anyway. Before we used to treat all these areas, these sectors, water, energy, and food differently. So now what we are working towards is understanding the interrelatedness and also interdependency of this, what do you call it, of these different sectors. So in the process, we hope to achieve a good one. We work on this. I'm trying to tell you my contribution to knowledge. We worked on Kaduna River. We used 3 years data to work on Kaduna River. And in the process, we were able to identify the correlation and similarity between variables, and we're able to classify the sampling size based on water quality. So the finding revealed 3 significant what we call clusters representing groups of sampling size with similar water quality. Also, we extended our research after working monthly for about 3 years. We extended the research to about 5 years. We monitor everything monthly from 2008 to 2012. Also, we worked on getting the factors that are affecting what we call temporary and special variation in water. So we analyze that. So we're able to classify the data into 2 seasons, the dry and wet season. And we're able to also identify factors responsible for water quality variation there. That's what we're able to do. And we'll have that in the iron part of the day. Also, we worked on Usman Dam. We're able to also classify Usman Dam. And we're able to identify the 4 principal components that accounted for 76.31% of the total valency, reflecting the impact of mineral suspension and human-related activity on the river hydrochemistry. So ensuring equitable access to water is a critical aspect of water governance and policy framework. So let's look at the conditions and strategies for promoting equitable access to water. Communities must be involved in decision making. Anytime you're taking this, especially the vulnerable and the what do you call it, the vulnerable and the marginalized group must be involved in decision making. And then also, that's equity. Also, another one is the policy and legal framework. Anytime you're establishing legal framework, you should recognize water as human right. That's the way of achieving what do you call it, achieving equitable access to water. Then also there is need for us to allocate resources to infrastructure and water supply. Very, very important there. Also in the area of pricing and affordability, there is need. Anytime we must make the price affordable. We have to look at the 3 or more than 3 what do you call it, segments of the society, so that we can do that. You don't just raise price without looking at whether the specific water needs and challenges faced by women and girls, because they bear the responsibility of water. And also in the area of capacity, we need to build capacity of workers involved in water supply. We need to quickly build their capacity. Very, very important. Also, there is need for us to explore partnership between the private solutions, but because of time, I might not have time. We have more than this, but we just brought these ones to highlight our areas of collaboration, but I will jump that. So let's move over to wastewater. Let's move into wastewater. What is wastewater? We need to I want you to know. I'm not here to make you a water engineer over 30 minutes. I'm only here to tell you my contribution to water. So what is wastewater engineering? It's a study, it's a field of study and practice that focuses on collection, treatment, and disposal, and reuse of wastewater generated. So if you look at that, what you can see there, we have 5 successive steps. You have the preliminary, you have the primary treatment, you have the secondary treatment, you have the tertiary, and then you have the sludge treatment. And all this, they involve combination of physical operations, chemical and biological processes to remove pollutants and ensure safe disposal of beneficial use of wastewater. In the process, we worked on this. That's the coliform removal coliform removal efficiency of what we call wastewater treatment plant. And we worked for 5 years. We were monitoring the whole thing from 2013 to 2017. Yes. So you can see the graph there. We're able to identify significant correlation between coliform removal efficiency and other constituents, BOD, COD, total suspended solid, and E. coli. And the coefficient of correlation range between 0.9 to 0.97, suggesting significant relationship between different wastewater constituents. You can see the regression there. And then also, we also took the data forward, same data. We're able to analyze and forecast the performance of wastewater treatment, that will part wastewater treatment here. So we use different methods. You can see many algorithms here. We use about 5 algorithms. And we're able to identify the one that has convergence, with the criteria we're using, convergence speed and prediction error. So at the end of the day, we got, you can see there, LM. That is the algorithm of artificial network. So we use it. So we're able to achieve a coefficient correlation of 0.96 and mean square error of 1.556. So the research demonstrated usefulness of artificial neural network in accurately predicting the performance of wastewater treatment plants. These are all high impact factor journals, CV and the rest of them. So we also worked on what they call it, prediction of performance efficiency using BOD. And also, for your information, we worked on this method. So you can use this method, I'm talking the last one, artificial network, to estimate your wastewater flow. So you don't need to be checking every day. You can use this model to be checking your, what do you call it, your wastewater flow. So let's look at the importance of water treatment plant. It plays a very crucial role. Remember when I told you that about 80% of wastewater you have globally, we discharge them without treating them, and because of that, they pollute the ecosystem you have there. So it plays very important role, crucial role in protecting human health, preserving the environment, and also promoting sustainable development. Very, very important that. You know. So because if you pollute the ecosystem, you're still going to take water from the ecosystem. So in the process, we worked on this. We studied the influence of treated wastewater on heavy metals on the soil also. We're able to advise. We came up with the need for adopting and improved sewage treatment processes that will eliminate the toxic, toxic materials you have there. You have in the treatment plant also. So now let's look at the sustainable wastewater treatment processes here. These are sustainable methods we can use: advanced oxidation processes, membrane bioreactors, constructed the wetland. That's a typical example of wetland there. We have there. We can use wetland also to do that. And also we can use what we call anaerobic digestion, which most of you are familiar with. At the end of the day, you produce biogas, and that biogas you produce, we normally use the biogas. Biogas is methane and and carbon dioxide at the end of the day, because it's anaerobic digestion in absence of oxygen. We have that. So also you can recover nutrients also from wastewater. Wastewater contains one of the popular one is just among them you have nitrogen and phosphorus. Also we can have that. Also we have ongoing research that is ongoing now on algae, also using photosynthetic microalgae, to treat wastewater while producing biomass. And this biomass, presently we are using biomass to produce fertilizers and produce diesel. So implementing sustainable wastewater treatment technology not only improves the water quality, but protects the environment and promotes resources recovery and also energy efficiency. So we worked on this. This is a Springer. We worked on this. We looked at the effect of hydraulic retention time on microalgae activated sludge. Here we use a batch, regimen batch, scale. We produce that. That's photo bioreactor. We produce that. So at the end of the day, you can see the graphs we got there. So there was a general decline. You understand what I'm saying? There was a general decline in the total phosphorus, a general decline in total nitrogen and phosphorus. So these are what you have there. So at the end of the day, we discovered that using micro-activated, sludge method is far better than the conventional, what you have in, we use presently now in FCT. So another thing is that when we talk about resource recovery from wastewater, we are talking about process of extracting and reuse valuable resources present in. Here we're talking about water, energy, and nutrients here. So when you talk about water, we're here now, we're talking about water reuse. We use water we have, we can use it for non-portable process or purposes. And then we talk about also energy. We can generate energy from wastewater treatment plant. We can do that. Also, we have, wastewater contains, like I mentioned before, nitrogen and phosphorus. We can do some nutrient recovery there. And then we use nitrogen and phosphorus, for our fertilizer. That's what we normally use. And also, you can have anaerobic digestion of organic matter here, where you can produce methane and carbon dioxide here also. Then also the issue of biosolid utilization. Biosolid is just organic matter remaining after wastewater treatment. That's what we have there. So you can also process it for our fertilizer. And it contains trace amount of metals. Also, we can recover metals from that. As I'm talking about wastewater. Now, let's look at, we work on this. Here in the area of bio-drying technology, this is also a severe. We worked on this also. So we're able to, the structure is not here. We find this one very effective in reducing moisture content of sewage sludge and facilitating its disposal. So if you look at this research highlighted the potential of bio-drying as a sustainable approach for managing sludge, sewage sludge, and also contributing to water energy nexus framework. So let's move over to solid waste management. You have 6 elements. They are functional elements of waste management. You talk about waste generation. Waste generation means creating waste. Then the second one, you talk about waste handling, separation and storage. That is what you do in-house. Then after then, the next thing is the collection. Collection is always by municipal or any other agency involved in that. That's it. And you have three routes you can take. You can send your waste to a transfer station. Transfer station is a place that serves for energy recovery. You can do that. And also you are at liberty to send your waste straight to disposal site. Also, you can send your waste to center for separation transformation. In transformation area, we have about several methods over there. You can apply thermal treatment. That's a heat treatment. That's what we call thermal treatment. It can be gasification. It can be pyrolysis. And then also we have a biological treatment when we talk about anaerobic composing and what do you call it, aerobic composing. So we have so many ways. Or you can only have chemical treatment. These are ways you can do that. I'm rushing because of time, please. Don't be angry with me. So these are our contributions to knowledge in the area of. We discover one thing. Collection component, especially in developing country, takes about between 50 to 70% of the waste management costs. So because of that, we went into that. We did research in that area, in the area of scheduling of solid waste collection rules. We worked on what you call Chinese postman's problem. Chinese postman's problem is based on Euler theory. By 16th century, it's a mathematical problem. How you can traverse a route without repeating the route. Because as long as you're repeating route, you're deadheading. We'll call it deadheading. You're deadheading. You're not collecting anything. Because distance travel is proportional to cost. So we're able to look at that theory. And we introduce capacity there. Because waste management is different from when you're moving around. Sending posts is different. Because you have a capacity. There are two constraints there. The vehicle has a capacity. Once it's filled up, you can't continue moving. And not only the vehicle has a capacity, also you have time. These are constraints. So we're able to introduce that theory there, and we'll work on that. I work with that. And then also we issue of arc routing. We worked on the second one is based on arc routing theory. We work on that, and at the end of the day, it's an heuristic method anyway. We're able to reduce the number of vehicles. We're able to save costs in the area of collection, and also we're able to save traveling distance. That's what we worked on that. Then the third one is we introduced what we call genetic algorithm. We worked on genetic algorithm there, and the research showed that the genetic algorithm-based program approach was effective in generating accurate and efficient solution compared to other methods we use. And then also the last one is an optimization. We use what you call mixed linear optimization method. And this model incorporated material balance and capacity constraint and associated refuse demand with sanitation zones. So we highlighted the sensitivity. We were able to do what we call sensitivity analysis. Those who are in economics, who are familiar with sensitivity analysis, looking at changing the objective coefficient and looking at what the objective function there. So these are some of our contributions in the area of this. So now this is one of the flow chart you have there. So now let's look at we're looking at circular economy. Our aim is to move to circular economy where waste is avoided. We keep on using waste. So the thing is that how do we prevent waste? So that is why if you look at most countries with a refinery, they always have a lot of petrochemical companies around them. So that any waste from there, you use it. So our plan is to reduce the number of waste we generate. So we're able to do that. So adopting sustainable solid waste management practices and embrace circular economy approach, Nigeria can reduce environmental pollution, conserve resources, create employment opportunities, and foster more sustainable development. So we also looked at the area of informal sector. For your information, in those days we used to call them scavengers. They are no more scavengers. They are waste pickers. You don't use the word. That word is not good for them. So we call them what? Waste pickers. So they play a very critical role in waste segregation. Very, very important. So we work on that. So we discover, at the end of the day, we discover that they can create under what we need. What we are working on now is how to bring informal into formal. In the process of research, we discovered only in Abuja municipal, we have about 50 recycling centers, plastic recycling centers, and they are illegal. Why they are illegal? They are illegal because they are informal. If you bring them to formal, you can work on them and to make the place. So the research provided valuable insight into activities and contribution of informal recycling sectors in Abuja, emphasized the importance of recognizing and promoting this sector for sustainable waste management and socio-economic development. So you also shed light on the challenges faced by waste pickers in this sector. Yes. Also, we worked on the area of this, also one of the best journals we have is Journal of Solid Waste in the US, Journal of Solid Waste Technology Management. So we worked on the solid waste generation and composition. Let me just tell you the truth. If you don't know the quantity of waste you generate, you can't manage waste. It's very important to know that. If you have a community where the quantity of waste there is just about, let's say, 30 tons, and you send a vehicle of 20 tons there, what are you doing to the vehicle? It's been underutilized. And then if the vehicle is 20 tons and you send about 5 tons vehicle, what it means you're not ready to pack the waste. So that's it. So here now we worked in a soccer there, and we're able to divide the town into 4 sanitation zones. And then also the analysis revealed high percentage of biodegradable in that place. It's about 70% there. And then these are some of, because of time, I did this in YM Makurdi, Uni-Agri Makurdi. My student is not here, who would have testified. So we did that in Uni-Agri Makurdi, but I don't have time because of time. We have to rush over there. So let's look at waste to energy here. Here now we are talking about waste to energy people are talking about is not the best, but it's an alternative. Yes, waste to energy is not the best, it's the lowest. I'm going to show you the hierarchy. You see, it's the lowest, is down there. So we are talking about pollution from there. But recently I saw one incinerator with very low emission anyway. So here now we are talking about incineration with energy recovery. No? Here now we generate energy heat, and we use this heat to do what? To produce steam, and also we use steam to drive what? The turbine to produce electricity. So that's another area. And then also we have pyrolysis and gasification. They all thermal treatment, and they are good system also. Here we use them to convert organic waste to synthetic gas. That's what you should have at back of your mind. And we have several innovative technologies. Just recently also, people are working on converting plastic to chemicals and the rest of them. So these are new areas also. Then because of that, just like I'm going to show you, someone just knocked his head and said, okay, no problem. Now let me tell you, for you to know, you don't just come up and say, okay, I want to convert this to energy. you must look at the energy content of what you want to convert. And how do you check the energy content? We have several methods of measuring energy content. We can use laboratory bomb calorimeter to do that. We can use the empirical method to do that through calculation. And we can use full-scale boiler to do that, to look at the energy content. That's the first thing you do before you start looking at how you can convert that. So we're able to look at how do we predict, how do we work on getting energy content, because it's good to know how you can. So we'll model it. We'll use 60 data sets, which we divided into two, 37 for testing for training and testing, and then 27 is for validating. That's a validating data set. We gathered them from Abuja here, and they are plastic, food, and the rest of them. So at the end of the day, the artificial intelligence produced results with absolute average percentage error of less than 9.13 for training and 9.4 for validating. That's what we use. And then secondly, the second one also, we worked on that. That's estimating the heat value of solid waste using neural network also. So these are we have so many of them. These are some of our constituents in one of the best, papers in the world. So now let's look at this, like someone asked me. Let's look at the hierarchy now. Waste hierarchy there. You can see waste hierarchy there. The emphasis these days is how to prevent generation, how to prevent destruction. Prevention is better. So that's the emphasis. You can see there over there. You can see the treatment you're talking about, thermal treatment. Everyone at the lowest place. So the emphasis is how do we prevent prevention. Then the second one is also by reduction. You reduce, you reuse, you recycle, and then you treat. So disposal, because initially when we discovered sanitary landfill, all of us started jumping that we have discovered something. Let everything move to what we call sanitary. But along the line, we discovered one thing. In the sanitary landfill, although we have controls over there, but at the end of the way you abandon them, we have an issue there. Because it produces leachate, that's the water from there, and it produces the biogas. We are looking at climate change. So because of that, the emphasis is don't take anything to disposal side again. That's the emphasis now. So because of that, it's at the lowest here. Because at the end of the day, you have leachate that pollutes the groundwater. You have the biogas that affects the climate there. So because of that, so the emphasis you look at, so it's not sustainable. Because the lifespan of a sanitary landfill normally is between 10 and 15 years. So you abandon it and move to another place. So let's look at the technological innovations in waste management. These are a lot of them. We have several cutting-edge technologies which we are applying there. Internet of Things, AI, blockchains, and these are so many things. But because of time, I will not go into details into that because of time. Also, we worked in, these are high-impact factor journal. We worked in the area of fuzzy logic, where this is a form of artificial intelligence. We use it to estimate, we use it to estimate solid waste generation. That's artificial intelligence. We use that. And we use to evaluate the optimal number of, waste bins in each of the areas. So the approach provided an integrated and comprehensive classification method for solid waste management. Also, we worked on self-organizing map. We're able to work on self-organizing map based on some variables, selected variables like population, dwelling, geographic, economic, education, and waste-related factors. We're able to use that to do this. So, and we're able to calibrate, or to assess, to validate and evaluate the whole thing using absolute average error and correlation coefficient. For correlation coefficient, we got about 0.982, an average error of 14.1, indicating high performance and reliability of the model in comparison with the measured data. Yes. This work, on behalf of my vice chancellor, I would like to tell you that this work is, I want to encourage young researchers. We did this work when we were young. So I want to encourage the young researchers. When I worked on this paper, I sent it to Europe, and one of the best journals, and the journal was rejected. And one of the things, I was in my corner, one of the things the man wrote there is non-esticker. Non-esticker, that was what he said, because I went against the rule. Instead of the graph going this way, I went the other way. That was what I discovered, and that's what I reported. The work was sent to the US. It was rejected in the US. And the same thing he wrote, non-esticker, because they are being funded by World Bank. So what I did was, I said, okay, let me go to opposite direction. I went to Iran. And I submitted the work to Iran. It took years over, well, you can see 2008 and 2009. Over 1 year, they were looking at, contemplating what do we do with this. But at the end of the day, I have 760 citations on this work. When it was finally published, today, as of today, 770 citations on the work. When it was, they destroyed the work. But at the end of the day, after being published, I got 770, as of today, 770 citations on this work, which the work they rejected because it went against their godfathers. So let's continue. So let's look at the social equity in waste and in solid and in waste and wastewater management. Social equity in waste and waste management and solid waste is crucial to ensure all individuals and communities in Nigeria have equitable access to these essential facilities. We must make these facilities affordable. I'm talking about facility, I'm talking about solid waste management, water supply, and I'm concluding, and the wastewater. We must make them affordable, the facilities affordable to people. Then also the communities must involve in some of these things, in decision making. We must involve them in decision making. They should be part of that, especially the marginalized group should be do that. We are talking about in the planning and everything. Then you talk about the health and hygiene education also. That's very important there. And then you talk about employment and livelihood opportunities also. We should be able to provide jobs and create jobs in the area of water, wastewater, and waste management there. And also issue of gender, like I mentioned, we should also recognize the women in all we do, because they are the people involved, at that level in the area of waste management and also in the area of what do you call the water supply. They are very important. They bear the burden with the responsibility of water collection and sanitation activities, especially not in the cities, especially in the rural area. So my conclusion. In conclusion, this inaugural lecture emphasized the importance of shaping a sustainable and equitable future in the critical sector of water, wastewater, and solid waste management. By integrating sustainable and equitable approaches to water, solid waste management, Nigeria can shape a future that aligns with sustainable development goals and ensure well-being of its citizens and preservation of the environment. There is need for us to work together towards a sustainable and equitable future, promoting the efficient use of resources, protection of public health, preservation of our natural environment for generations to come. And I want to talk to my fellow researchers, because why I'm giving this information is that I'm ready for collaboration. My research is just starting. So for young people and also for senior colleagues, I know Professor Mustafa is here, Maoga. All due respect, sir, former Vice Chancellor of Modibo Adamawa University. So I'm ready for collaboration. So I want to tell my colleagues this. It's our responsibility to generate knowledge, foster innovation, and disseminate best practices. So coming to my recommendation now, that's the conclusion. We have a bill before National Assembly. It was there before. I don't know whether they have moved it to the second assembly. It was there in 9th Assembly. It was not approved. There is need for we to urgently approve the bill. Those people there, some of them are here, to urgently approve the bill. Because the Water Act of 1993 cannot address glowing water management challenges. And then also the issue of, the issue of integrated approach. We need to implement integrated approach to water management that considers the water cycle. And then also my colleagues in the academies, we need to promote research and innovation in water, wastewater, and solid waste engineering in Nigeria. There is need for us to invest in training, capacity building, and building initiative for water, wastewater, and solid waste for professionals also. And then there is need for us to invest in development and maintenance of water facilities or infrastructures there. There is need for us to foster economic community engagement, community participation in decision-making relating to water, wastewater, and solid waste management. Also, we need to pay attention to marginalized communities, ensuring that they have access to water, safe water, and solid waste management, services. My Vice Chancellor, my esteemed colleagues and friends of water resources who are here, and wastewater and solid waste engineering. Solid waste holds immense potential to shape a sustainable and equitable future. The quest for a sustainable and equitable future requires a paradigm shift in our approach to water, wastewater, and solid waste management. Let us rise to the challenge together. Forge a path towards a world where water resources are protected, wastewater is treated effectively, and solid waste is managed sustainably. I hope this research inspired further research, collaboration, action towards effective and sustainable waste management practices. Thank you for your attention, for joining me on this journey towards a waste-free and energy future. Thank you. And then currently, let me tell you what we're doing now, presently. We have an ongoing research. I'm collaborating with a lot of people on this campus, especially people from biology and the rest of them, microbiology and the rest of them, in area of exploring the potential of microbial fuel cells, anaerobic digestion, and algae-based system for energy generation and nutrient recovery in the context of wastewater engineering. That's ongoing research here. And then also, I'm particularly focused on addressing challenges faced by developing countries, including informal waste sector, inadequate infrastructure, associated health implications. And I'm excited to be part of this work. And I look forward to collaborating with others to make a difference. And in future, I hope to dive deeper into the development of innovative treatment technologies to improve the removal of pollutants and achieve higher pollutant quality standards. I hope that's in future, that's my future. And overall, let me summarize. My research interests are centered around finding innovative solutions to enhance waste management processes, improve water quality, and promote sustainable practices in the field of water resources and environmental engineering. Thank you. Mr. Vice Chancellor, permit me at this junction to thank and acknowledge all those who have contributed one way or the other to the actualization of my academic dream. My Vice Chancellor. My life has been influenced and shaped by a lot of people. So many people. Some are here, some are not here. But first and foremost, I want to thank the Almighty God for making it possible for me to be here today to deliver my inaugural lecture. The road was rough, but we thank God at the end of the day. That time I wrote on my paper. You know what I wrote on my paper? There is always a light at the end of the tunnel. I came to the University of Abuja in 2007. And how I came here was a miracle. My former university, I had this policy. On Fridays, I always stay in the house to do. I was at the department. I always stay in the house to work. I applied to University of Abuja. I never bothered to come to University of Abuja. But on that particular Friday, something happened to me. Say, go to work. That was the first Friday to go to work. I got to the office. You know what I saw? A DHL from University of Abuja asking me to report on Monday for interview. Without knowing any person in University of Abuja. I was the second person to be interviewed. The first one was Professor Sadiku. Just to tell you, my coming here is divine. I never planned to be here. I wanted to go with my godfather, who was the vice chancellor of Umudike. We were together in Uniagric Macaulay, Professor Onido. But along the line, the dynamics changed, and I came here. So I want to thank God for that. And also, I want to thank all of you for coming here. And also, apart from shaping my life, let me just tell you, my wife, she's there. I always tell her, she's a professor of computer science. Yes. She came from NDA. Most of you might not know her. She was the dean, faculty of what do you call it, military science in NDA. She's now the head of department of computer science in this university. I always tell her, when I come back in next world, I'll find her and marry her. She has been so sound. She's my pillar and support. I want to appreciate her. And also I want to appreciate my father. My father will be online watching the system, yeah? She had seizure 2 days ago. He's in the hospital. He would have loved, but he's online. Because I sent the link to him. I said, watch. So, and my sisters are not here because they are with him in the hospital. They had seizure. So he's in the hospital now. But I want to thank him. I want to thank my mother for all the effort they did, all the things they provided for me. They gave me the best. Even with little salary, they were able to give me the best. I want to thank all of them. They're online. And I also want to thank my sisters, Ogochukwu, Obinna, and Chinwe. I want to thank all of them. I also want to thank my uncles, Oliver. They are too numerous to mention, and my cousins, my nephews, and all of them. And also another source of my strength is my mother-in-law. Also another source of my strength. She's a professor also. So I married professor. And I want to recognize my children there. I want to recognize my children. Stand up. And then the other one, that's Tochukwu Jr. That's the Tochukwu. That's my namesake. That's the Tochukwu Jr. They're all wonderful kids. I want to thank them. They will also be professors. And then I want to thank my professors, who tutored me and who nurtured me. Even when I was a baby, sometimes I would do. They taught me, let me just tell you, if you work with a great man, you become great. When I came into academies, you know what they told me? It's loading. When I came into academies, So when I came into academies, you know what they told me? When you want to publish locally, the man will call me, Professor Agwamba. When you work with a great anything, that's what he calls local journal. So he told me, if you don't publish in Elsevier, you don't publish in Springer, you don't publish professional, forget about it, you have not published anything. So they started early to guide me. So that's why my vision is, these are things I focus. If you don't publish there, you forget about it, but you have nothing to publish. It takes time. They criticize your work, but it's better you do the right thing. So I want to thank all of them. I want to thank Akunne Onitsha, that's Professor Ebuniwe. He's late, of blessed memory. He tutored me. I want to thank Professor Ademuliye. These are people who tutored me. And also Professor Agwamba, my mentor. He has everything. He does everything for me. And then I want to thank him. And not only that, I want also to thank my researchers, my research team, my collaborators, my former students. One is supposed to be here, but he said he cannot come. I'm happy for him also. The Minister for Water Resources was my student in the University of Agriculture. I taught him 300 level hydrology. I taught him at 500 level. He's supposed to be here, but maybe because of office work, he didn't come. The new one, they just appointed. And also I want to thank my colleagues and students in Faculty of Engineering for the support they've been giving me. I like that. They appointed me, the family ward, they appointed me and they re-elected me again. Can you clap for them? And then also I'm grateful to University of Abuja for providing me with opportunity to serve. I'm grateful to Professor Abdulrashid Nala and his team for making it possible for me to give this inaugural lecture. I want to thank all of them. And I also want to thank all the past vice chancellors of this great university. They made me to be of service to this great university. I appreciate all of them. And then I appreciate fellow professors, all teaching and non-teaching staff, too numerous to mention at the University of Abuja. You're wonderful. I like most of you. I like all of you. And also, And also, I'm grateful. Yes. I'm grateful to my colleagues also in the Faculty of Engineering for the encouragement. And also, I want to be grateful also to the chairman of the Inaugural Lecture Committee, Professor Gbangboye Kolawole and his team. Thank you for your support. You're wonderful. They kept me on my toes every minute of the day. Are you ready? Are you ready? Are you ready? So I want to appreciate all of them. I want to appreciate my distinguished guests who are here, attendees, presently who are here. I can see Senator Clever Ikisipo. You're here, Senator. You're here. And also Honorable Ubika, that's Honorable Representative Amak and Buari Area Council. I want to thank you. You're wonderful. And also Professor Mustafa, former Vice Chancellor of Modibo Adama, my godfather, with Bunu Sharif, they were all together. And I also want to thank Engineer Jibril, Executive Secretary, former Executive Secretary FCDA. Thank you for that. You're wonderful. And I also want to thank Engineer Ali Rabiu, that's the former former president of Karen. I want to thank you. And I also want to thank Senator John Damboyi, my friend. Thank you. So I want to thank all of you, the captains of industry that are here. I want to thank all of you. And also I want to thank also Professor Smiler. Where's Professor Smiler? Yes, Executive Director FEMA. And I want to thank all of you for coming. Also the family, community, engineering family, I want to thank all of you. That's a wonderful one. Thank you for coming to honor me. I'm very grateful to all of you. So I sincerely thank all of you. Thank you for listening to me. Thank you, sir. Sorry, let me just acknowledge